Hey guys, welcome back to another video. In this video, I'm going to revisit the code I did in the Actix TODO Service video series. The link is in the description if you want to check it out. I will write a couple of unit and integration tests, and I'm going to use Github Actions to run the tests against the database every time I push some code to the repository. This will be an opinionated walkthrough. As always, do your research and take my advice with a grain of salt. Okay, let's first talk about unit tests in this context. To create a unit test for, let's say, a function, you need to be able to call the function, pass in the correct parameters, specifying the signature, and then verify that the result is what you expect by doing some assertions. If we look at the code we created for the TODO service, we can see it is made out of external dependencies. Can we easily instantiate those dependencies, or do we have control over them? Probably not, and we don't need to test the behavior of the external dependencies. Tokyo Postgres and Slug already have plenty of tests in their respective projects. You only want to test your own logic, and to be able to do that, the dependencies should be loosely coupled. We will need to do a lot of refactoring to be able to have unit tests. We need abstractions. We can use patterns like dependency injection, factories, adapters to find the dependencies in terms of threads. I found that mocking is a bit limited in Rust, or at least not as easy as other languages. One of my favorite books is called Working Effectively with Legacy Code. I will leave the link in the description. It will teach you many techniques on how to refactor and to extract dependencies from the code to make it testable. Maybe unit testing techniques or how to write testable code for Rust deserves its own video series. But as they say, you must choose your battles. Let's look at the handlers, for instance. We have this web data wrapper. We may be able to instantiate this using what Actix provides. But then we have the app state that contains the logger and the connection pool. We'll need to encapsulate that, maybe create a wrapper for the logs and abstract the details of the own macro we have here for context. And we may be able to have an abstraction over the connection pool, maybe an object store, a repository, or a DAO. It will be similar for other handlers, and an integration test looks like a better approach for this. What about the DB methods? Not much logic to test here. It will be a lot of work to mock just the client, to create the prepare statement, call the query, convert the rows to our object, and test the different error conditions. Trying to mock this just looks like another lost battle. What about the errors module? We do have control over the app error, and it is easy to instantiate. We also have some logic over the user-facing message, the status code, and the response. Let's give it a shot. The convention in Rust is to create a test module inside the file you are testing. This is just the convention. You can actually have your test in a separate file, as long as you don't need to test private functions or structs. The other convention is to annotate the module with the CFG test macro. It tells Rust to compile and run the test code only when you run cargo test. Tests won't be part of your final binary. To write our first test, we just need a function. I want to test the default message for the app error. Let's say I have a DB error, no user-facing message, and I don't have the cause either, and the error type is DB error. Now we can do an assert equal. The error message in this case should be the default message. An unexpected error has occurred. The last argument of the assert is the failure message, in case the messages are not equal. Let's write default message should be shown. Now we just need to annotate the function with the test macro, so it runs with cargo test. Okay, let's run it, and it passed. We can see the module of the test and the name of the function. Now let's make our test fail, so we can see what it shows. There is a panic and it says assertion failed, and it shows both messages, left and right, and the failure message we wrote for more context. Let's write another one to test the custom message. The user-facing message will be unable to create item. And in the assertion, we expect to see that instead of the default. for the failure message, user-facing error message should be shown. Now we can run it, and we can see there are 2 tests now, and both passed. It's really straightforward if you don't have any dependencies, or at least if you have control over them. Okay, now that we have some tests, let's push the code to GitHub. We want to run the test every time we push code to the repository. For that, we can set up a GitHub action. GitHub detected that we are using Rust and recommended a quick start action to build and run the tests. So let's use that. Click on Setup this workflow, and it basically creates a YAML file with the description of the action in the .github/workflow path. The YAML file defines the steps. We can see cargo build and cargo test. There are a couple more actions that we can add, like a cache for the dependency. We'll talk about this later. For now, let's change the name of the action to tests and commit the file. Now that I did that, if we go to actions again, we can see the action running with the commit message, and it says there is one process running. The action has several steps. It will do an initial setup, we'll check out our code, and after that we'll build our app and run the tests. We can see it is downloading and compiling dependencies. It will take some time to finish. In total, it took 3 minutes, and we can see it ran the test we created. That was easy. Now, let's talk about integration tests. This is how it is defined in the Rust Lang book. In Rust, integration tests are entirely external to your library. They use your library in the same way any other code would, which means it only calls functions that are part of your library's public API. So the convention in Rust is to have the integration tests in a separate test folder in the root of a project. But that means we won't have access to the code we wrote unless we treat our project as a library or an external crate that we can import. That means we will need a lib file, and I will have to expose some APIs so it can be imported in the integration test. Another approach could be to test our app just as a REST API. For that, we'll only need an HTTP client in the integration test, and then we are done. Well, there is another option actually. Rust's definition of integration test is like an end-to-end test or a black box test, but you can also have white box integration tests. After all, their purpose is to test whether many parts of your library work together correctly. And Actix has a guide on how to do this kind of test. So let's break the convention for now and see how this plays out. Let's go to the main file and create a module integration test with the config test macro, like we did with the unit test. Since we have asynchronous code, we also want our tests to be asynchronous. Let's try to test the getToDo's endpoint. The regular test annotation won't work here for the asynchronous function. Luckily, Actix got us covered with the Actix runtime macro for the test. Now, let's first create an instance of the app. We can move the factory closure to a name function and use that, but let's do this step by step for now. First, we need a new instance of the app and the app data. We have our first dependencies in the app state, the connection pool and the logger. So let's tackle both. The connection pool is configured using the environment variables in our config struct. The log have different configurations, so it could be a good idea to also move that to the config struct. So let's move the configure log function. And now we can call it from config. But we also need to move the imports. Let's copy the code for the configuration to our test. The code to create the pool looks like another good candidate to be moved to the config struct. Create a function configure pool that will return the pool, move the imports, and we can call it like that. Okay, now we can add the route we want to test, the /todos with the getToDo's handlers. Following the Actix documentation, let's import the test module for Actix Web. It has a lot of helper functions. Let's put the app in a variable, and instead of an HTTP server, we can use the test module to initialize a service that takes the app instance as a parameter. We use await and assign it to a mutable variable. Okay, now we want to create a request for that route. For that, we'll use the test request builder. This will help us to create many types of requests. In this case, we want a GET request. We specify the path URI, will be /todos, and then call to request. Now we can call the service using that request and assign the response to a variable. We use call service, passing the mutable reference of the app and the request. Finally, we do some assertions. For now, I just want to make sure the service returns the correct status code. So assert equals the response.status will get me the status code, and I expect it to be 200. In case of failure, the message will be get todos should return status 200. Good. Now let's run the tests. We can see that the test failed. It got a status 500. You can see the reason of the failure in a critical error log saying error created in the client and that I cannot connect to the server. We need the database to run the test. So let's start the database and try again. Cool. Now our test passed. We just need to be careful with this kind of tests. Tests will run in parallel. There is no guarantee that it will run in order. So I need to make sure they are self-contained and don't depend on other tests. For instance, counting the amount of returned records may not be a good idea, but I could test that the body is parsed correctly. Let's create another test to cover a more complex case. We just need another async function with the Actix runtime macro. Now, we need to do the same as the previous test, but there is a problem. We have a connection pool. Do we want to create a connection pool for each test? Maybe we can set the pool to size 1 and create it in each test, but what about the logger? Can I have more than one root logger? I'm not sure. Let's try an alternative approach. I could have the app state as a static reference. This can be done with a library, and since this is only for tests, I can add the dependency as a depth dependency. The crate is called lazy static. This library has a macro that will allow me to have a static member that I can initialize in runtime. I just need to import it, then call it like that, and inside I can define a static reference to the app state. Remove the code to initialize all the configuration and create the app state instance. Then I should be able to use this everywhere. I missed the semicolon there. And one more thing, my app state needs to implement clone, so I will do that. I just need to use the derive clone macro, and we are done. No more errors. Let's run the test again to make sure everything works. Good. Now back to the test. Let's copy the code to create the app, and this time I want to include the get todos and create todos. We initiate the service and let's define the title of the to-do list we want to create, say create to-do list. And we can do this in many ways, like using the create to-do list struct. But let's create the request as a JSON. To make things simpler, let's include a dependency on certi.json and import the JSON macro. We can write a JSON just like this, title and the to-do title. Then we need the request. Again, we use the test request. It will be a post request. Then define the path, and we need the content type header for the application JSON. The payload will be the JSON string and call to request. Finally, we call the service we did previously, and we can do some assertions. Status code should be 200 for the post request. Next, we can get the body of the request by using read body. It will get us a bytes buffer. We can try to deserialize the body. So let's import the to-do list model. We use certi.json from slide and pass the reference to the buffer. In the assertions, we can check if the result is okay. Otherwise, the response could not be parsed. After that, we can unwrap to get the to-do list. We already tested the creation. Now I want to check that the getTodos endpoint returns the list that I just created. So we create another get request for /todos. But this time I want to get the JSON response as a vector of to-do list. We do that with the read JSON response. From that vector of to-do lists, I want to find the one that I just created by checking the IDs. I should have an optional value as result. So in the assert, I just need to check if the optional has a value, so is some, and that means it founds the to-do list. So the failure message will be to-do list not found. Now we can save and run the test again. And the test passed. Great. Let's commit and push to GitHub to see what happens. Add integration test. The push fails because I made a commit from GitHub, so I can just fetch all and rebase. Now I should be able to push. Good. I can see the build is running in GitHub. It should take about 3 minutes and it fails as expected. If we look at the logs, we can see it got a 500 status and the client could not be created because we don't have the database yet. So we need the Postgres instance and a way to create a database schema. Right now, we have a single SQL file to create the database. We could just use it with a Postgres CLI, but we can do better and have a proper migration tool. So let's install DSL CLI with Cargo, and we only want the features for Postgres. Once it is installed, we run DSL setup, and it will create a couple of things for us: a DSL toml file and a migration folder. We'll ignore the DSL file for now. Let's create our first migration by running DSL migration generate and the name of the migration, in this case create-db. We can see it created a new folder for the migration along with two SQL files, up and down. Up contains the statements to make the changes to the database, and down, as we can read in the comments, should undo everything we do in the up script. So let's copy the create tables to the up script and the drop tables to the down script. We don't want to have the dummy data in the migration. Now let's try DSL migration run. It tells us that it needs the database URL as a parameter or as an environment variable. Let's pass that as a parameter with the database URL. It should be Postgres, username, password, @hostname, port/database. The hostname is actually localhost. We fixed that and it fails because the relation already exists. So let's connect to the database and drop the tables. We try again and it succeeded. If we run it again, nothing happens. Good. After the test run, we may have garbage data. We can clean that up by running DSL migration redo. It will apply the down script and then the up script after it. Good. Now let's look at the GitHub action again. We need to be able to run the migrations here. So let's add a step to install DSL with the same command we use. Besides that, we need a Postgres database. That can be done by adding a service. We call it Postgres and use the Postgres Docker image. We also need to define a couple of environment variables to set up the database and expose the default port for Postgres. One last thing, since the database service can take some time to start, we need to wait for that before running the test. Otherwise, they will always fail because the database is not ready. For that, we'll use a health check command. Postgres provides a handy utility script called pg_is_ready that checks the connection. We can use that. Let's run it every 10 seconds with a 5 second of timeouts and up to 5 retries. Now let's add another step to actually run the migration. After that, it will run cargo build and test as before. One last thing, the environment variables, they should be different depending on the environment. So let's move the original and have it as an example in the repository. We can have another one specific to GitHub, and then let's add the .env file to the gitignore file so we don't push it by accident. One last thing, let's change the environment file for GitHub since we use a different database configuration. In the GitHub action, I will add a new step to copy the .env file for GitHub. Let's commit, add DSL migration and update GitHub action and push. Okay, it started to run in GitHub. Let's wait for a couple of minutes. Great, the test passed. We now have a GitHub action that builds our app and runs the unit tests and integration tests every time we push something new. Usually, the video will end here, but it takes 7 minutes to run the test. That's not acceptable. We can do two things to improve this. The first thing is to set up a cache for our dependencies. That way, it won't have to download and compile them on every build if they did not change. We saw that there is a cache GitHub action that we could use. It should reduce the time it takes about half. The second thing is to have a Docker image that already has the DSL CLI, so we don't have to install it in each build. I'm sure we can find an already existing image in Docker Hub, but just for fun, let's do it ourselves. First, we need the base image. Let's use the official Rust image. It has plenty of documentation on how to use it. I will use the 1.41 slim version. So let's create another Docker file for the cache. It will start from the image we picked. I will create a cache directory for the working directory. And I will also need to install libpq for Postgres, because that's required for TODO to work with Postgres. We want to keep the size of our image small, so we delete the package manager cache files after we are done. Then we can call the TODO CLI. We can also delete the cache files, but it should be good for now. Next, what we want to do is create an empty cargo project with cargo in it. Specify BCS none so it doesn't create a Git project for us. Then we copy the cargo.log file and the cargo.toml file to the cache folder. Finally, we run cargo build, then we remove any Rust file we created, and the build result is available in the target folder, in this case under debug. For this, we also want to remove the files with our project name, since it was just an empty project. So I will remove everything that starts with my project name. Cool, that should be all for the Docker file. Now I will create a new repository for my Docker image in Docker Hub. Let's call it TODO Actix cache. Good. Now we should be able to push the image once we build it. To build the image, we run docker build -f to specify the Docker file we created for the cache, then the tag that should be our username / the project, and optionally a build number, otherwise it will just use the latest. Finally, the context, that is the current directory. Oops, if you see that, that's usually not a good sign. Let's stop it. We need to create a docker ignore file and ignore the target folder. Good, 300 kilobytes instead of 3 gigabytes. We'll need to wait a couple of minutes to finish downloading and building dependencies. I got an error, there was nothing under target debug folder, so it should be the dependency folder. We fix that and try again. Good, we have a new Docker image. We can push that with docker push and the tag name. Let's wait a couple of minutes. The image is about 2 gigabytes in size. It can be optimized further, but should be good for now. Let's change our GitHub action file so it uses our image. We do that by specifying a container. All our steps will be executed in this container. The image is just a repository in Docker Hub. We can use tags in the future, but for now latest is fine. We can get rid of the TODO install step. Instead of that, we will move our cache target folder. The database host also changed since we are using a container. We need to use the name of the service instead of localhost, so it will be Postgres. The rest will stay the same. In the .m file for GitHub, we also need to change the database hostname to Postgres. Let's commit and push that, and it started the build. It will take more time initializing the container because of the size. We can see the health check here in action. Let's wait until it's finished. Great. Now the build took 10 seconds and running the test took 8 seconds. If we manage to reduce the Docker image size, we may have tests that can run in a minute. If you compare that to the 7 minutes, that's a huge difference. You may be able to use the cache GitHub action and a Docker image that already have TODO, but this was for sure fun to do. Let's do one more thing. What if you only want to run unit tests, but not your integration test? Well, we can put our integration test behind a feature flag using the config macro. And we just put feature equal to integration. Then in the cargo.toml file, we add a features section. Below that, we have our default set of features without any special dependency and our integration feature. If we save and run the test again, we can see that only unit tests have run. To also run the integration test, we pass the feature argument with integration, and now it runs the integration test. Great! And that will be all for this video. Did you find this video useful? Let me know in the comments. If you liked the video, hit the like button and don't forget to subscribe for future videos. It will encourage me to create more and better content. Thanks for watching.